Okay, we continue with the low orbit satellites. Uh, as you can see again, by considering that this orbit here, that is a very low orbit. Compare that with the geostationary orbit, which is a very high orbit. So, uh, so you must understand also that for polar orbits, uh, as you said, that they are limited in use, meaning that if you want them to operate continuously, you must have several satellites. For example, Starlink needs Starlink, the company which has got the internet that we use even in Central High, he has launched thousands of satellites into the atmosphere just to maintain their network. Then we have what we call geostationary satellites. Geostationary satellites orbit above the Earth's equator. So this one, where it is orbiting, is above the Earth's equator. We know that polar orbit, as I said, they orbit and pass through the North Pole and the South Pole of the Earth. But this one, it orbits continuously above the Earth's equator. The orbit of the satellite is 24 hours. So it takes 24 hours to go right around the Earth. Uh, so that's what it does. This one, not necessarily that it's going down right around the Earth, but to move throughout that circle, which we call the orbit, it takes 24 hours, and it's at a height of 36 kilometers above the Earth's surface, much higher than polar satellites. Remember, polar satellites it's about 200 kilometers, but this one is 36,000 kilometers, which is a very high distance from the surface of the Earth, used for radio communication and, and telecommunication broadcasting around the world due to its high orbit. So this one, because of its high orbit, we don't need many of them to be able to broadcast. So usually most of our satellites for dishes for our television, we use this geostationary satellite, not the polar orbit satellites. Uh, Now let's go bigger, a little bit deep into the system of communications. Many important systems of communication rely on long wave electromagnetic radiation. So what do we mean? We mean that for there to be communication, usually you must use a long wavelength electromagnetic radiation. Remember, from radio waves have the greatest wavelength. As we come from radio waves until we reach gamma rays, radio waves have the greatest wavelength. We use those wavelengths with the greatest wavelength to do our communication. So, take for example mobile phones and wireless internet and satellite television. This uses microwaves. Microwaves, they come after radio waves and they've got a very large wavelength. For Bluetooth, for example, if I want to connect my phone to a phone or even my phone to the car radio, we use Bluetooth. Bluetooth, terrestrial signals and radio stations, they use radio waves. Optical fibers, they use infrared or visible light. Still, if we are to read in order, we start from radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays. So the three that we have talked about there, microwaves, radio waves, and infrared, are the ones with the greatest wavelengths. These are the ones that are used for communication.